Today, let's check out Terraform as a means to codify our cloud infrastructure needs. In advance of today's exercise, let's install Terraform, the Azure CLI, and obtain a free Azure account. Those are all linked in the description below. As per usual, I've created a new directory for today's exercise. If you did the last exercise with Azure Web Apps, you'll want to delete your resource group. Just make sure that in the Azure portal, you don't have the previous Web Apps resource group around. That might conflict with what we're going to be doing if you're following along exactly to the T. All right, so the first thing we're going to want to do, we'll create a new file, main.tf. The most significant part of this is that TF is the extension, but this is just like a YAML file. And in here we can define some things. The first thing that we'll want to define is the provider that Terraform is going to look to for what are the definitions for different bits and pieces within the scope of the cloud infrastructure we'll be terraforming. To specify our provider, we're going to start with Terraform, within which we're going to say required providers. In here, we're telling Terraform, hey, we're going to pull down some stuff. This is the stuff we need you to pull down, dependencies. We're going to pull down Azure RM, and then we're going to specify where is that coming from and what version. So we'll pull it from HashiCorp. That's Terraform's company directly. We're going to version, and we're specifying the version. I'm choosing 2, but 4.6.0. It's just because that's one I've commonly used, but there may be a more up-to-date one as of the time you're performing the exercise. Further, we're going to specify the provider now, which is the Azure RM. We're just setting that up in case we need to pull down more features later. But for now, wrong brackets. For now, this should do. So now that we've told Terraform, hey, we need you to pull down dependencies so we can do Azure-specific things, let's do some Azure-specific things, right? We're going to need resources. And in fact, we know that we're going to need a resource group, an app service plan, and an app service. We know that because that's what we did on the previous exercise. But if you haven't done the previous exercise, it's all good. We're just going to create a web API hosted in Azure, and we're going to do that leveraging a GitHub packages hosted Docker image. So all of this is free, and if you follow along exactly, you'll be able to access it as well. So to specify a resource group, these are all specified in the docs, but you can just say Azure Resource Group, and you can give it a little label. I like non-zero, very relevant to this channel. And then I know that this resource type, resource group, has a name and a location. So for name, we're going to continue the paradigm of RG- for resource groups, and then we'll do non-zero packages. And then for location, we'll do West US 2. That's just where I'm located, but if you want to do something closer to you, feel free. Very easy and convenient, and it'll be faster for you if you do. Next, we'll want to make an app service plan. So to make an app service plan, we will start with resource once again. You'll note that's a practice that's very common. Azure RM app service plan. We'll do a non-zero label there as well. And then this has a number of different attributes. So we'll do a name, SP-non-zero packages, SP being service plan. Location, let's just use the same location as we used for the resource group. And there's a little trick that we can do to do that, which is that we can specify, hey, look at the resource group and the non-zero one in particular, and just leverage that location. So now we're using the location that's the same as the resource group, which is, I think, useful. Next, we're going to need to know the resource group name. So we're saying, hey, what resource group does this live under? To do that, we're going to, once again, specify, hey, look at that non-zero one, that one that we looked at before for location. Just use its name. And then for kind, this is going to be a Linux service plan. We can make it reserved if we want. And for the SKU, this is really important. This is the part where money gets spent or doesn't. We're going to say it's free. And we're going to say it's the F1 size. Cool. This will define our service plan. And finally, we're going to want to create our app service or define our app service so that we can create it. We can do that once again with the resource Azure RM app service, and we'll label that once again the non-zero instance of it. There's a few moments in here where we're going to once again refer to the other resources to grab things like location and name. We'll start with the name being app-non-zero packages. And then we can go with location equal to the, in fact, we can just copy those guys, location and resource group name. Those are just going to be pulled from the resource group again. And then for app service plan ID, right, we're going to need to specify the service plan. We can just reference the service plan, the non-zero one, and its ID. There we are. Beyond that, we're going to need a site config, and that site config is like, hey, what are you deploying here? And in this case, we're going to deploy our Docker image from GitHub container registry. So we can simply do this as a Linux FX version. Not necessarily intuitive that it's named that way, but then we'll follow a naming paradigm Docker in all caps, type ghcr.io, and then we're going to specify where we are pulling our package from. If you followed along in the last exercise, the Azure App Service one, you'll note that this is the same one as before, but now it's just done in one nice little string. And then we have to do this as use 32-bit worker process, as of the time that we're recording this video at least. Cool. So now this should be an app service that deploys our Docker image. It belongs to this app service plan, and all of it is under the same resource group. So if we need to clean up, we can clean up one resource group. So in order to run our Terraform stuff, if we're going to deploy to Azure, we need to have a context that has Azure logged in. To do that, you would do az login, and that will just take you to log in through a web browser. The next step will be to run Terraform init. This pulls down those dependencies. It creates a Terraform lock file. You'll note here it's finding and installing Terraform or HashiCorp's Azure RM. That's what we're going to leverage to actually implement or push up, create our resources. There's another step that you can choose to do, which is Terraform FMT. That's going to format the code. I think our code is not too complex, but for legibility purposes, you can note it's actually, it's gone ahead and made it a little bit nicer to read. I tend to like doing this just for this reason. It's a little bit easier to read. And then you can do a Terraform plan. Now, plan doesn't actually do any, persist any changes, but what it does is it looks at the current state of your logged in subscription, your AZ logged in subscription, and says, hey, does this exist? If not, we'll need to create it. If it does exist, should we change it? Is there something that shouldn't exist that we need to destroy? And so it goes through and it plans out what would that look like. And since I don't have anything from this, it's a pretty clean slate on the subscription that I'll be playing in. It's just going to add. If you want to, you can actually persist the plan. But in this case, I think I'll just be happy to run Terraform apply. Nobody else is using this subscription at this moment, so I'm just competing with myself. But by doing Terraform apply, I am persisting those changes. If we weren't careful about our SKU being free, this could persist some costs. So make sure that your SKU for that app service plan is free. It will ask you, hey, you sure you want to do this? At this point, you'll type yes. I really want my resource. So now that Terraform apply has finished, if I go into the portal, I can see, hey, in resource groups, I've got my non-zero packages resource group, under which we have our app service and our app service plan. Now, it might take a little bit for the app to actually pull the image coming from GitHub, the container registry, from GitHub packages. But once it's all happy dandy, you can click that URL, go to the /swagger, and see, hey, here's the Swagger page that's relevant to that image that we've been playing with. And if we call the weather forecast, we'll get some random weather. And if we go to configuration, you'll note we didn't set any app settings. So we should expect for the configuration endpoint, which just returns the non-zero value configuration or environment variable, it's getting a 204. There's nothing there. So next, we can play with how do you set a configuration or an environment variable within the Docker image that is in context here. We navigate back to our Terraform definition, the main.tf file. We can add a node that says, hey, app settings, we're going to set those equal to, and in here we'll have, in quotations, non-zero value, and set that equal to day. And now, if we go through the same steps we did before, running the Terraform commands that did things like formatting and pulling down dependencies, we should be able to persist up a app service instance that has our configuration. So I ran Terraform init, format, and plan, and you'll note that the plan just has one to change. So in this case, we're not adding a bunch. It knows, hey, we're just going to add our setting. There's not a lot going on here. We can just go ahead and apply, and all we'll do is we'll change a little bit. So I applied the Terraform changes, and now over here in the Swagger instance that we had up before, by executing, we see day as the response type now. Today we leverage Terraform as a means to capture what we intended to be our cloud infrastructure for our application as something in code, right? So this is the notion of infrastructure as code. I think there's a number of parts of this which leveraging documentation is going to help a lot, and I'll include the documentation, the Azure documentation for Terraform in the links in the description below under additional resources. But beyond that, it's not too verbose, which makes it pretty usable. It doesn't matter if you're playing Azure or if you're playing in AWS. It doesn't really matter which cloud platform you decide to play with there. Terraform does leverage something that's not too verbose as a means to capture what your infrastructure will look like. Beyond that, if you have some additional time, you might check out some of the other documentation that's included in the additional resources below. But if not, congrats on a non-zero day.